All right, so I'm going to try and do the entire 45, 50-minute lesson in as short of amount of time as possible. Yeah, the audio quality probably won't be great, but let's give this a shot. We're going to do polynomial long division today. This is when we have a polynomial divided by a polynomial, and the polynomial in the denominator is not a monomial, as you see in the example on the bottom, x squared plus 5x plus 6 divided by x plus 2. How do I divide x plus 2 into that trinomial? And so what we're going to do is we're going to see that it mimics the wonderful world of long division. It's not exactly the same, but it's very similar. And of course, we remember, how do we do long division? Well, we would do the 11 into the 3. Doesn't go in. 11 into the 38 goes in 3 times. We multiply the 3 times the 11, 33, and then we subtract. We drop the 0. 11 goes into 50 4 times, 44. We got a 6, drop the 6, 11 goes in there, right, 66, no remainder, so we know that it goes in evenly. We're going to do something very similar with our x plus 2. The biggest difference is we're not going to ask the question, how many times does x plus 2 go into the entire thing? We're just going to look at the leading terms. All right, we're going to look at the highest degree term in my divisor, which is the x, and the highest degree term in my dividend, the thing that's being divided into, which is my x squared. So I'm going to say, how many times does x go into x squared? Well, it goes in x times, right? Because x times x would be x squared. Now, the trick here, of course, is that when I put an x up here on top, I have to multiply it times both things in the binomial that's dividing in. So I do x times s is x squared, x times 2 is 2x. And then I'm going to do the same thing. I'm going to take both of these terms and I'm going to subtract them from what's above. X squared minus x squared is 0. 5x minus 2x is going to be 3x, and then I drop the 6. Then I'm going to do it again. I'm going to say, how many times does x go into 3x? It goes in 3 times. 3 times x is 3x. 3 times 2 is 6. I get no remainder, and I am done. In the same way that I could multiply 346 times 11 to make sure that I do get 3,806. Obviously, I could FOIL x plus 2 times x plus 3, and I should get x squared plus 3x plus 2x plus 6, or x squared plus 5x plus 6, which of course is what I started with. All right, let's look at another example. 17 into 228, or 2x minus 1 into 6x squared minus 7x minus 2. Well, if we did 17 into 228, 17 goes into 22 once, right? 17, we get a remainder 5, 8. 17 goes in 3 times, we get 51, and then we have 7. Now, remember that a long time ago, before you were much better at math, we used to say that the answer was like 13 remainder 7, right? Then you got a little bit better at math, and we said that it was 13, and then we took the remainder 7 and made it 7/17 because 17 was the number you were dividing in. Certainly, we know that we could just keep on dropping zeros and get a decimal approximation, but this is where we're going to stop for our analogy, so to speak. Let's see what happens when we do our work on the trinomial divided by the binomial. Again, we're going to ask the question, how many times does 2x go into 6x squared? If you want to think about it in terms of what number could I put here that would multiply times 2x and get 6x squared, right? Or 6x squared divided by 2x as a monomial divided by a monomial. So that goes in 3x times, but I've got to multiply the 3x times the 2x. and the 3x times the minus 1 minus 3x. Be careful here. Remember that you are subtracting everything, right? So it's kind of like distributing. You're going to have a negative 7x minus a negative 3x. In that case, we're going to be left with a negative 4x, right? And we're going to drop the negative 2. 2x goes into negative 4x, negative 2 times. Negative 2 times 2x is negative 4x. Negative 2 times negative 1 is positive 2. Be careful. Remember that you are subtracting all of this. Negative 4x minus negative 4x is 0. Negative 2 minus 2 is negative 4. Notice, I have a remainder. How do I know not to drop anything? Well, there's nothing left to drop. How do I know that 2x can't go into what the remainder is? Well, notice that this time I've gotten to a point where the degree on the 2x, right, this is a degree of 1. This is degree 0. You can't have something of a higher degree go into a lower degree. So in that case, what we're going to focus on is writing the remainder. We're going to say plus negative 4 over 2x minus 1, just like we did over here where the remainder was 7, and we put it 7 over 17. A lot of people will rewrite this as 3x minus 2 minus positive 4 over 2x minus 1, just because they don't like doing the plus and negative, right? And so what we have is a polynomial long division problem in which it doesn't go in perfectly. It doesn't result in a polynomial answer, remembering that 2x minus 1 being in the denominator makes it not a polynomial, but that's okay. If we actually multiply 2x minus 1 times 3x, 2x minus 1 times negative 2, and 2x minus 1 times negative 4 over 2x minus 1, we would get our 6x squared minus 7x minus 2. All right, let's look at another one. If you looked at this one, you might be tricked into doing something bad. What is the trick here? Well, what's wrong with the numerator? What's wrong with the numerator is it's not in order of decreasing degree. In order to do this polynomial long division type stuff, x plus 3 into, it's only going to work if you do them in order of degree. That first, right? That's third degree. Then do your second degree, 4x squared. Then do your first degree, minus 2x. Then put, so you've got to sometimes reorder them. And now we're going through the same process. Leading term into leading term, right? How many times does x go into 2x cubed? That would be 2x squared times. 2x squared times x is 2x cubed. 2x squared times 3 is 6x squared. When I subtract these, I'm going to get 0 minus 2x squared. I'm going to drop the negative 2x. I'm going to ask the question again. How many times does x go into negative 2x squared? That's negative 2x times. Negative 2x times x is negative 2x squared. Negative 2x times 3 is minus 6x. Remembering that I'm going to subtract these, negative 2x minus a negative 2x squared is going to be negative 2x squared plus 2x squared, which is 0. Always going to get a 0. I'm trying to eliminate things just like in the other form of long division. Negative 2x plus 6x is 4x plus 12. How many times does x go into 4? It goes into 4. Let me make that a better 4. 4 times. 4 times x is 4x. Ooh, I like this. 4 times 3 is 12. I get no remainder, and so my answer is 2x squared minus 2x plus 4. If you actually do the binomial times the trinomial, you'll get that answer. All right. Finally, there's the case of the missing term. This one's a little tricky, all right, just because people tend to get confused if they try and do this. Notice that here it is in order of decreasing degree, but I'm missing a term in a way. I've got an x squared, I've got a constant, but I've got no x. one of the things that's really helpful is to put a placeholder there. Instead of writing underneath the little house x squared minus 4, I'm going to write x squared plus 0x's minus 4. Just because, as you'll see when you do the polynomial long division, you're going to have x's in there when you start multiplying things in your answer to your x plus 2. And so it's just nice to remind yourself, oh yeah, there might be some x's. In this case, I don't have any x's, but x's are going to be involved in the problem. Because what happens when I start? I ask the question, how many times does x go into x squared? It goes in x times x is x squared. X times 2 is plus 2x. A lot of times, if they just have the minus 4 there, right above the plus 2x, people get confused. So it's just a nice thing to do. Remember, I'm subtracting both of these things. X squared minus x squared is 0. 0x minus 2x is minus 2x minus 4. How many times does x go to negative 2x? Minus 2 times negative 2, negative 2x. Negative 2 times that is negative 4. I'm subtracting both those things. I get a 0. And of course, x plus 2 times x minus 2 should be x squared minus 4. All right. Those are some wonderful examples. Let's do one more just to run through and see, or maybe you can pause it and try it yourself. This one involves all of the work that we're doing here, missing turn, lots of crazy stuff, all sorts of fun. So pause it, try it, and then come back, start it again. Okay, you're back. We're going to do x plus 1 into 3x to the 4th plus 0x to the 3rd, my placeholder. I got an x squared, I got x's, I got, oh my goodness, this is going to go on forever, isn't it? All right, are we ready to go? How many times does x go into 3x to the 4th? It goes in 3x to the 3rd times. 3x to the 3rd times x is 3x to the 4th, and 3x to the 3rd times 1 is plus 3x cubed. I'm going to subtract and get negative 3x cubed. I'm going to drop my negative 7x squared. X goes into this one. Negative 3x squared times negative 3x squared times. That's going to be minus 3x cubed minus 3x squared. I'm going to subtract that, so it's going to add 3x squared, so minus 4x squared. I'm going to drop the minus 3x. This goes in negative 4x times, negative 4x times that is negative 4x squared. Negative 4x times 1 is minus 4x. That's going to be a negative 4x, so that's going to be a positive x plus 15. How many times does x go into that? Plus 1 time, x plus 1. My remainder is going to be 14, so I'm going to write plus 14 over, well, I'm dividing by x plus 1. That is your answer. Woo! That is your homework. Good luck, and hopefully you had a good time at the VNA or when you were doing other things, and that's why you missed class. That's about it. I'll see if it works. Bye.